Thanks, everyone. Good morning. And let me introduce myself. I'm Moied Wahid. I'm responsible for the developer experience at PayPal. What developer experience means is in the code to cloud, the whole tool application lifecycle management. My teams are responsible for making our developers productive and keep them humming. At PayPal, our mission is to democratize the financial services so that the people and businesses can thrive in a global economy. In just Q3 earnings call, we processed 114 billion payment volume, and which is an increase of 30% year over year. And we actively support 218 million active accounts, and which is up by 90% year over year. And if you can think about the magnitude, continuous delivery, it's a very critical piece. And we talked about the philosophy of DevOps and all those things. But at the same time, delivering without impacting our customers is a critical part of our journey. So if you think about the scale we operate, right, we have 4,000 plus engineers who are hands-on keyboard, writing code on the keyboard. And they operate on 70 million lines of code with different stacks like Java, Node, and C++. And every change goes through a PR. That PR does code reviews, static analysis, PMD, find bug, you name it. Different stack has a different checks and balances, guardrails, in order to meet and adhere the quality. If you look at 5,000 Jenkins instances we have, and we do 32,000 builds and 1,000 deploys a day. And just not that. If you think about it, we run 1 million test cases a day. And that generates 7 billion hits on the sheer test environment. It's just the test environment. And we operate just the dev test workload runs on 30 racks. So the scale is huge. And when you deal with the scale, how do we do this transformation of DevOps and bring agility in our development environment? The approach we took was, I think, it's a very common approach in any industry, is we look at the pipeline and looked at where the choking points are, and we addressed one at a time. I was just sharing the story with Angela, which is not part of my presentation, but we started with a source control system. And the source control system, it used to take 3.5 hours when I joined PayPal to just do a clone from a clear case. And at that time, we had 9 million lines of code. And we migrated this whole company with different source control systems. We used to have CVS, Subversion, and other systems. And now it takes less than a minute to clone when we have 70 million lines of code. So I'm not going to go through the entire journey, but I'm going to double click on 3 major focus areas: our build system, our CI infrastructure, and our test systems. The reason I feel it's very critical is we believe in providing rapid feedback to our developers so that they can iterate faster. When I joined PayPal, it used to take 8 hours to do a build. And the reason being is it was very monolithic code base, tangled, grew over years, like 15 years. And the core of the code was based on makefiles. And if you know, makefiles are based on timestamps. You cannot do incremental builds. And we had our proprietary frameworks like messaging and other things. And it's very hard to bring agility and break the code apart. We had an initiative for code breakup. but that didn't go anywhere because it's very hard to do these things. And I was sharing Angela that the picture she put up there about the how hard it is to do this DevOps journey. I feel you almost need to have an irrational optimism in order to make this happen. And that picture is very resonating because it talks about it's all dirty, but at the same time, you need to have that optimism and passion to do this. You need to take one thing at a time. This is like 7 million lines of code tangled. It's very hard to do. And it used to take forever to do a build. And what happens is developers, they need to be in the context. They need to be in the zone. If you're making a change and you get the feedback 8 hours later, you lose the flow, you lose the thought process because 9 million lines of code, it's very hard to debug also. You don't know the context. If you make this line of code change, what kind of functionality you will impact with, because it's a very monolithic, tangled code base. So we went to drawing board. We started with POCs, thinking about how we can intelligently find out the dependencies. My talk is going to be a little bit nuts and bolts, so I hope that's okay with you guys. So we went to the drawing board and thought how we can do it from scratch. What we did is we looked at, we did prototypes on how we can smartly learn about the dependencies and do the build avoidance. The trick is you cannot build 50 million lines of C++ code from scratch, because if you compile one C++ file, it goes to the disk 11 times. That's not possible. The physics doesn't allow that. So what we did is we figured out the best way to do is we look at the change set, what got changed, and based on that, what need to be built, so that we can do a build avoidance and reuse the hash. So we created a build system that creates a hash of hashes. First, we look at if you change a line of code, foo.cpp, what need to be built? And we've identified those content. And for rest, we reuse the hash, reuse the artifacts. Not only the file gets hashed, but the artifacts, the .os, the exes, the binaries get hashed. This is based on how Git's approach of doing things. And not only that, we did extreme parallelization. And when the build is at peak, we have a special hardware that runs the Arik is laughing. This special hardware that runs this build. And when the build is at peak, the CPU utilization on that box is 95%. 95% for that 1 minute. I'm going to transition to the CI journey. I'm going to say, if you guys have more details, I can give you more details on CI, how we did the build system and other things. So our CI journey. When we started our CI journey, we started with Hudson, when Jenkins was Hudson. And people used to write some scripts to do build and deploy and all those things. But it was not scalable. When we rolled out Jenkins to PayPal, we had 40,000 jobs in a single ginormous instance. We had to reboot the box every single day because Jenkins had this object memory leak, and and it chokes after a while. So we have to recycle that box every single day. Then we said this central model is not going to work for us. And we want to empower developers. At PayPal, we value the empowerment, freedom for our developers. And we move from a central model to a federated model where every developer gets their own Jenkins instance. That's like its own VM. what this allows developer to do is bring their own plugins, to play around with it. Because if you have a central instance, if you want to do a find bug plugin, and you are in a different version of Java, and there's a lot of conflicts and stuff like that, we have to verify. The time to market was very slow. So everybody gets a Jenkins instance. And we had 2,500 Jenkins instances. And we looked at, developers were very happy about it. But as a DevOps team, we were not happy about it because we were not utilizing the fleet efficiently. Only less than 10% of these Jenkins instances were active, which is waste of resource. And we migrated this whole Jenkins infrastructure to Mesos. With Mesos, it allows us to spin off Jenkins instances on demand. We have long-lived masters, but Jenkins slaves we spin off on demand. So we reduce our footprint from 2,500 VMs to 100 VMs. And also provided the same agility and speed to our developers and freedom. Then we realized that when we spin off 2,500 Jenkins instances on the fly, there is a drift from Jenkins slave to slave. The Java version you use, I use is different. So what we did is we Dockerized that whole Jenkins infrastructure. And people can bring their own custom stack. They can bring their own Docker container to this ecosystem. And that even allowed us to accelerate our innovation. Not only that, we provided real-time monitoring. We not only have a system monitoring at how the CI as a service performing, how Jenkins uptimes are there, what is our build 90th percentile takes, what's the breakdown in the build, there are 10 steps in the build, what is a Maven breakdown, Maven time, clone time, packaging time, compiling time, linking time. So we had a lot of insights at a very coarse, fine-grained level in each build step or deploy step. Then we moved to, with this Dockerization, people started exploring Blue Ocean pipelines. And Blue Ocean is another Jenkins offering through which you can do a complete end-to-end pipelines. And there's a huge adoption of Blue Ocean at PayPal. This is a very cornerstone for us to bring that agility in our DevOps journey, our test infrastructure. And when I talk to a lot of companies, and most of them have a similar problems. Test infrastructure is a huge, huge pain point to enable. I think Angela touched upon it, and you also touched upon it, on how the challenges about functional testing, integration testing, and other things. PayPal, when we were having 30 services, we used to run everything in one box. That's like PayPal in a box. Everybody gets their own instances. We had 5,000 of those. And as we grew, we moved towards a service-oriented architecture. We had 2,900 plus services, and the binary size itself was like 250 gigs. And it's simply not possible to run everything in one box. We had one box with 80 core, half a terabyte of RAM, but still the services were failing. We were not able to even bring up. So people created a subset of the services. People want to test, let's say I'm working on payments domain. I created a profile where I run probably 300 services. I have some other domain. I am responsible for making sure the compliance and risk works fine. I created another 500 services profile, and I run only those. But what happens is when we run these services, you're siloed. You're testing your own domain. You're not testing everything. And what happens is, the integration testing becomes really hard, and finding bugs at the later point of the time in the PDLC is very expensive. If you look at every sprint, we did the Agile transformation and other things. I'm not going to go through that. It's a topic by itself. So developers at PayPal, every 2 weeks, they secure a virtual machine that they can run all these services. They write the code, they deploy the services, and they have to worry about, I don't know if the point. So they have to worry about keeping up the services, because over a period of time, it chews up all the memory on the box, and it was pain point. They have to figure it out, which services I'm dependent on. And it is a huge pain point for our developers. Troubleshooting failed services and keeping them up, and also revving up. Every 2 weeks, there are probably 300 services that get changed. So you have to rev all these services, and it's a huge challenge. And developers come to work to write code, not to deal with this, keeping up the services, understanding the dependencies. It's just painful process. When I talk to developers, they say that they waste like 30 to 50% of their time, maintaining these test environments. We said, we're going to tackle this. And the next bottleneck was our test environment. So we created a shared test environment that runs on Mesos. And if you look at what Mesos allows you to do, it dynamically allocates a compute resource to a particular service, and we can maintain a highly available environment. And you can flex up, flex down, and all this good stuff. The key thing here is, we also wrote a service discovery and registration model. Whenever the service we install, when we start a service, it registers to the zookeeper, where we maintain an itinerary of which service is running on which box and at what port. And we wrote a software router that reads from this database and knows exactly which service is running on what host at what port, and it routes the calls based on this routing table that's defined in this database. And another thing, Aurora is a scheduler on top of Mesos. What that does is, if the service, it continuously monitors the service. If service goes down, it spins up another node so that you have highly available system.
Is that an internal system or on the cloud?
So we have our internal cloud. We moved our dev test workload to a public cloud. But that is our initial testing the waters to figure it out, what is the strategy should look like. If you look at internally, we have a huge hundreds of, I can't give you the numbers, but we have hundreds of thousands of nodes on OpenStack. So the secret sauce of this test environment to be successful is that software router we wrote. I'll tell you, it's okay, we have, if the whole company is working on one version, and you have a shared environment where everybody tests. But let's say you're also iterating the code at the same time. And how do you test that with what's running in live and not disrupting everything in the shared test environment? Let's say if this is my service A, B, C, D, and let's say I'm iterating on a service A, I don't want to deploy an unstable code in the shared test environment. What I want to do is, I want to run it on my local laptop or a small VM. So this infrastructure itself is like 3.5 racks. Just to give you a magnitude of how big it looks like. So now I have to I'm working on the same service A, and I'm iterating it. And I want to see how my code A will behave with this 2,900 shared services. I can mock it, but that's, as you all know, practically it's not going to work. And it, the interfaces have to be same and all those things. There are another set of challenges. So now I have a prime that I'm iterating. What we did is, when you start up your A here on your local laptop or even on your private VM, it registers back to the zookeeper, the central routing table. So every request that starts from this local development environment or a user test stage, it goes to A prime, even though your service A is running on the shared environment. Let's say your code flow is A, B, C, D, E with what's in live. You basically point your test cases to this endpoint, a test environment, and the code path will be, the call graph will be A, B, C, D, E. But let's say you're iterating your code and you're also changing the service C. What happens here is, the call will start from A. Even though A is running here, it will use A prime here, and it will use B from here, and it comes back and uses the C prime here and goes to D. This is very critical, in order to make this whole thing work. And this didn't happen overnight. This whole journey, it's a journey, and it's like a 2 years journey to get to where in a state that we feel good about it. So now developers, they don't have to worry about keeping up their dependencies and other things, because they worry about their own application A, and they code and they deploy that on your user stage or on your laptop, and rest of them comes from a shared test environment. And that allows developers, reduce the 30 to 40% of their engineering waste time. If you look at when we started what this whole thing, the whole pipeline changes we did for our source control system, to our build system, to our CI system and test system, the impact to developers is, we used to have 25 manual steps in order to, you file tickets, you get approvals, and this whole shebang, right? Now we have a PaaS layer where, developers can go to a site and say that, I'm writing a Java app, and we create a repo. Once you go to that site and call it out, what stack your application you are working, what service you are trying to build, we create a repo, we create a Jenkins job, we create a pull request, we provided sample code. If you make any code change, the pull request automatically triggers a build and provides all the rails, does the static analysis, has a sample test case also. So I'm going to contrast between what happened 3 years ago and now. We have, steps to production. It used to take 25 manual steps. Today it's completely automated. Time to market, weeks to days. And the QA deployment used to take like 5-6 hours. Now it takes less than 30 minutes. The build time used to take 2.5 hours to less than 2 minutes right now. And production deployment times used to take 4 hours. Now it's less than 30 minutes. The infrastructure, provisioning and capacity planning and other things used to take months. Now it's less than 30 minutes. So why do we do this? It's very critical for us to provide, as I said, rapid feedback to our developers. When we started this journey, it used to take months. Now it takes less than 24 hours. And our goal is to get this whole cycle time in less than 5 minutes. That's about it. Any questions? So I have 1 minute warning.